What if I told you the green energy revolution is physically impossible with the materials we have right now? Not because of politics, not because of funding, because we literally don't have enough copper in the ground that we can access in time. Robert Friedland, a guy who's built mines on 4 continents, said something that should have made headlines, but didn't. He said we need to mine the equivalent of 10,000 years of copper extraction in the next 20 years. 10,000 years in 2 decades. Let me put that in perspective. Humanity has pulled roughly 700 million tons of copper out of the earth since we figured out how to work metal. Every wire, every building, every circuit board, all of it adds up to 700 million tons. Now, to hit net zero by 2050, we need to mine that same amount again. The entire span of human metallurgical history, repeated in 25 years. And here's the part that keeps me up at night. Nobody's talking about whether that's even possible. I spent the last 2 weeks going through geological surveys, mining company reports, and IEA forecasts. The numbers don't work. They just don't. And the gap between what politicians promise and what mining companies can actually deliver is getting wider every single day. Let's start with the most basic question. Why do we need so much copper? Electric vehicles. A normal car with an internal combustion engine uses about 23 kilograms of copper, mostly in the wiring, the alternator, basic stuff. A battery electric vehicle, 83 kilograms. That's 3.6 times more copper per car. Now multiply that by the tens of millions of EVs governments are mandating over the next decade. But it's not just cars, it's the grid itself. To meet 2040 climate goals, these are official IEA numbers, we need to add or replace 80 million kilometers of power lines. 80 million. That's enough to wrap around the Earth 2,000 times. Every single one of those kilometers needs copper for transmission. And then there's the thing almost nobody's factoring in. Data centers. AI is eating electricity. ChatGPT, Claude, Midjourney, all of it runs on massive server farms that need copper for power distribution and cooling. This wasn't even on the radar 5 years ago. Now it's a major demand driver that's completely outside the green transition narrative. So demand is exploding. Got it. What about supply? This is where it gets ugly. Global copper demand right now is about 26 million metric tons per year. By 2035, that's barely a decade away, we're projected to need 50 million metric tons. We need to double production in 10 years. Has that ever happened before? No, not even close. Here's why. Copper doesn't just appear. You don't turn on a copper mine like you flip a light switch. The average time from discovering a viable copper deposit to actually producing metal is 16.5 years. 16.5 years. That's discovery, feasibility studies, environmental assessments, permitting, financing, construction, all of it. Let's do the math. If we discover a major new copper deposit today, in 2026, it won't produce a single ton of copper until 2042. That's past most of the aggressive EV mandates, past most of the 2030 and 2035 climate targets. The projects that will supply copper in 2035 should have been discovered in 2018. Were they? I looked. The answer is no. Between 2012 and 2022, the mining industry went through what insiders call the lost decade. After the 2008 financial crisis and the commodities crash that followed, major mining companies stopped exploring. They focused on capital discipline, paying dividends, buying back shares. Shareholders wanted returns, not risky greenfield projects in unstable countries. So we have a 10-year gap in the pipeline, and you can't just backfill that. Geology doesn't care about your policy goals. But let's say we somehow find the deposits. There's another problem. The copper that's left is harder to get. In 1970, the average ore grade, the percentage of copper in the rock you're digging up, was about 1.5%. Today, it's 0.59%. We're down to 0.5%. That means for every ton of copper you want, you have to move and process 200 tons of rock. Think about what that means. More mining, more water, more energy, more diesel in haul trucks, more grinding, more smelting. The carbon intensity of producing copper is going up, not down. We're burning fossil fuels to dig up the metal we need to stop burning fossil fuels. Nobody wants to talk about that paradox. And it gets worse, because the easy deposits, the ones close to the surface, in stable countries with decent infrastructure, those are gone. The new frontier for copper is places like the Democratic Republic of Congo, Mongolia, Zambia, places where you're dealing with corruption, political instability, and zero infrastructure. Even in safe jurisdictions, it's a nightmare. In the US and Europe, permitting a new mine takes over a decade because of environmental litigation. NIMBYism is real. Everybody wants electric cars, but nobody wants a copper mine in their backyard. I looked at a case study. The Resolution Copper Project in Arizona, one of the largest undeveloped copper deposits in the world. It's been in permitting hell for over 20 years. 20 years. It's still not approved. Meanwhile, over 40% of global copper supply comes from just two countries, Chile and Peru. Both are facing massive political instability, water shortages, and labor strikes. Chile's copper production has been flat or declining for years, despite rising prices. Peru's mines get shut down by protests. In 2023, the Cobre Panama mine, which supplied 1% of global copper, was shut down overnight due to public protests and a Supreme Court ruling. 1% of global supply gone, just like that. That's the new reality. It's not just about geology anymore. It's about social license, about resource nationalism, about communities saying no, even when the economics say yes. So, here's where we are. Demand is doubling, supply is stuck, and the time lag to fix it is longer than the policy timelines. What does that mean? Prices should be going through the roof, right? That's basic economics. Except copper prices haven't exploded the way you'd expect. Why? Because the market doesn't believe the demand forecasts. Traders think one of three things is going to happen. Option 1, substitution, aluminum. It's cheaper, more abundant, and you can use it for high voltage transmission. The problem? Aluminum only has 60% of copper's conductivity. You need thicker wires, heavier wires. That works for some applications, but not all. You can't just swap them out one for one. Option 2, technology saves us. There's a company called Jetty Resources working on a leaching process that can extract copper from low-grade waste rock that was previously uneconomic. If it scales, it could unlock millions of tons of supply from existing mine tailings. That's a big if. The technology isn't proven at scale yet. Option 3, demand destruction. This is the dark one. The theory is that copper prices will rise so much that EVs, heat pumps, and solar panels become too expensive for normal people. Governments will quietly roll back mandates. The energy transition slows down or stops. The market balances because demand collapses. Goldman Sachs has written about this. It's not a fringe theory. Here's what I think people are missing. The entire green energy transition is predicated on the idea that we can electrify everything without hitting physical resource constraints. But we are hitting them. And the response from policymakers has been to double down on targets without auditing the supply chain. California says no new gas cars by 2035. The EU says the same. But nobody's asking, where's the copper coming from? China figured this out years ago. They don't produce much copper ore, but they control about 50% of global copper refining capacity. They've been locking in long-term supply deals in Africa and South America for a decade. They're not hoping the market figures it out. They're securing physical metal. Meanwhile, Western automakers are starting to panic. Tesla, Ford, GM, they're all making direct investments in mining projects now. They're bypassing the traditional commodity markets because they don't trust that supply will be there when they need it. There's one more wild card: deep sea mining. Companies like the metals company are saying the ocean floor is covered in polymetallic nodules that contain copper, nickel, cobalt, everything we need. They say we can harvest them without traditional mining. Environmentalists say it would destroy ecosystems we don't even understand yet. The UN's International Seabed Authority is supposed to regulate this, but the rules aren't finalized. Some countries want to move forward, others want a moratorium. It's a mess, and even if it gets approved, it won't produce meaningful supply until the 2030s at the earliest. So where does that leave us? Best case scenario, we muddle through. Some substitution happens, some new technology works, some mines get approved. Demand grows slower than expected because EVs stay expensive. We hit 2050 climate goals, but later and with more compromises than anyone wants to admit. Worst case, we hit a hard supply wall around 2030. Copper prices spike. The energy transition stalls. Governments blame mining companies. Mining companies blame permitting. Everyone points fingers while the gap between ambition and reality becomes impossible to ignore. There's a third scenario nobody's talking about. What if the whole framework is wrong? What if trying to electrify everything at once is the problem? What if we need a completely different approach that uses less material intensity? I don't have the answer, but I know the current plan isn't working. Here's what keeps me up at night. We're making trillion-dollar bets on a future that requires materials we haven't discovered yet, from mines we haven't built yet, in countries that might not let us build them. And we're pretending it's all going to work out because the alternative is too uncomfortable to consider. Maybe it will. Maybe engineers will figure out substitutes. Maybe new mining technology will unlock supply we can't see yet. Maybe demand will moderate, but maybe it won't. And if it doesn't, we're going to hit 2035 and realize that all those EV mandates and climate targets were based on assumptions about copper supply that were never realistic. The green energy revolution isn't failing because of oil companies or climate deniers. It's failing because we're running into the physical limits of what the Earth can provide in the time frame we've decided we need it. That's not a political statement. It's geology. So here's my question for you. If the copper isn't there, what happens to the plan?